happy weekend, happy long weekend for some of you. Hopefully you have a long weekend. My name is Aubrey, in case you are just now joining in, obviously from Aubrey Teaches. And I am starting a series of mathematics videos for elementary mathematics. I'm currently in grad school with my ultimate goal of becoming a math coach, so I'm becoming an elementary mathematics specialist. So to kick off this series, I'm talking about my math lessons and how I structure them. So there are 4 components that I use when building a math lesson. And I want to tell you off the bat that my math lessons are only 25 to 30-ish minutes. They're not incredibly long. And we also utilize math stations in my room, so I'm seeing small groups, and I'm not going to talk about that in this video, so I'm just talking about my whole group lesson. So I'm going to talk about the 4 parts that make a high quality math lesson today and not really go in depth, because I know some of you are going to be like, I have this math curriculum, I have this math book, and it's not like that at all, and I don't know how I would make this work. And don't worry, I'm going to be making this a series, and we're going to be diving into how you can take what you have and tweak it and make it work, where you are covering the content and the concepts you're supposed to be covering and that your students need based on your standards, but also making it high quality and deep and conceptual. So I'm going to talk about these 4 components that can make a math lesson really more deep, more conceptual, and more meaningful. And then in some following parts of the series, we'll talk about each one individually and how to really make that work in your classroom. The first component of a high quality math lesson is really mind-blowing. Are you ready? It's review. Shocking. I know I'm the first person to come and tell you that a really good lesson starts with review, right? No one's told you that before, but it is true. Now there is a little bit of difference in how I build my reviews versus some traditional reviews. So I keep my reviews really short, usually 4 to 5 questions in a quiz form. I use my kids' iPads. You can use a paper, it doesn't matter. I review concepts and strategies over just reviewing that kids can give me numbers and answers. For example, instead of giving my kids a quiz that says 6 times 3 equals, my quiz might say 6 times 2 is 12. How can that help me discover 6 times 3? And what I want them to be able to tell me is how they can use their strategy for 6 times 2 is 12 to connect on to 6 times 3 is 18. And I want them to be able to talk and walk me through that and talk and walk each other through that. So we're reviewing their strategies, we're reviewing their mental math capabilities, we're reviewing their deep conceptual understanding instead of just reviewing that they can get answers correctly to me. So really putting in that review for whatever concept we've been talking about, but more strategy based. So that's the first component, is a review. And that's very, very short, very, very simple, quick discussion with kids, moving on. Okay, the second component you've heard me talk about, and I have a whole video over, so I'm not going to drone on about it. You can go watch that video if you want to. It is number sense routines, number sense warm-ups, number sense games, number talks, whatever you want to call them, they need to be in your math lessons daily. So a number talk can actually look like anything. And a lot of people think it has to be this one certain thing and that it doesn't belong in a geometry lesson or it doesn't belong in a measurement lesson, and that's just not true. So these deep concepts of number are actually going to strengthen your kids' conceptual understanding of fractions, of measurement, of geometry, of all these things. So you really need it in every single lesson. So if you need some ideas for warm-ups, you can go watch that video where I talk about number talks, games like favorite number. It's simple as sitting in a circle and counting by tens, counting by hundreds, seeing how high we can count in a minute, counting by 15s, starting at 1,000 and counting by hundreds. It can be what's my rule, where the kids give me a number, I do something to it, and they figure out what I'm doing to it. In and out circles. For example, my students and I just did in and out circles the other day. It's a circle on the board, that's all you need, and you need some kind of rule in your head. So the one I used was multiples of 4. So multiples of 4 went in the circle. Anything that was not a multiple of 4 went outside the circle. And students give me numbers. I put it in or out of the circle. They have to figure out what's going on. And we put about 85 numbers up there. They filled this board up, filled our whiteboard, and they couldn't figure it out. They knew all the numbers inside were even, but there were some outside that were even. They were yelling and shouting and so excited at math time, trying to solve this and figure it out. And it was time for us to go to math stations. I said, I'll leave this on the board. They said, what? You're not going to tell us? And no, I wasn't going to tell them. They went home, they were thinking about it at home, they came back, they were wanting to know, they were thinking, they were stumped, and then one of my kids in the afternoon got it. They said, I think it's 4, so we walked through it, and they were like, oh, they were losing their minds. They were so engaged with that one little quick warm-up that I did, and they were thinking so deeply about numbers. So it does not have to be something crazy hard, just something simple. So totally doesn't have to be something crazy, but some kind of number sense warm-up. It can even just be getting them to do some problems in their head, giving them a problem, giving them a number string, something simple like that. So we have review, and we have number sense routines or number sense warm-ups. So the third component of a high quality math lesson is something I'm going to touch on, and I'm definitely going to have more videos on because it's very important and not very prevalent and really, really difficult for a lot of people to wrap their minds around. And that is a high cognitive demand math problem. And I have a blog post about this, so I'll link that too. But a high cognitive demand math problem is one problem that is high cognitive demand. That means the students are really having to think deeply. They're having to use a lot of cognitive deep thinking in that one problem. So instead of giving them a worksheet of many problems, like most traditional math books or math workbooks do, where the students are either already understanding the concept, so they fly through it, they don't understand the concept, so they do it all wrong, or they catch on to what's happening in the first few problems and then they just copy and paste for the rest of the problems. And they've done all of these things, all of this page, but they really haven't had much high cognitive demand. So what we should probably be working towards is having 1 or 2 or a few really deep problems where the students are thinking a lot and they're thinking really mathematically and really conceptually. And you can do that by taking problems from your textbook, from your workbook. Many people have talked about this before, and twisting them, turning them on their head, getting rid of a lot of them, getting one really high quality one, and giving that over to your kids. And for this to really work well, you'll probably need to start implementing some kind of groups or partnerships in your classroom. So we use math partners. My kids always have a math partner. Or sometimes we use math groups. I call them math partners or math triangles. The triangles are 3 kids. Or math squares, that's 4 kids. So they know to get in their math partnership, their math triangle, or their math square, and they just immediately get in those groupings. You also want to give them a lot of access to supplies. So when my kids are working on a high cognitive demand problem, they have each other. They have access to whiteboards, dry erase markers, paper, pencil, their iPad, which has like digital whiteboard on it, and all of our manipulatives. Yes, we spend a lot of time at the beginning of the year talking about what manipulatives are and how we use them and setting that up because free reign is going to be absolutely nuts. But my students do have free access to math manipulatives at this time because that's how they're going to really think through these problems. I haven't told them the steps to take. I haven't told them the formula. They're going to be really thinking deep. And they're going to need some stuff to do that. So you need to have some kind of way your students are working together, and you need to have access to a lot of different manipulatives. And you're going to pose the high cognitive demand problem, one problem to your students. I put it up on the screen. We talk about it. It's a real life problem, something that can make sense to them. And then I send them out in their math groupings, and they use whatever tools they need to start grappling with the problem. And then what do I do at that time? As the facilitator of learning, I'm walking around and I'm checking in with groups and partnerships of kids. And I'm doing this for a few reasons. To gather information and assess my students, to know where they are, taking little notes, mental notes or physical notes, see where my students are getting stuck, where their thinking is, if they have any misconceptions, if they have some gaps in their learning or anything like that. Assessment. Also, I want to know my kids' thinking. And I want to know my kids' thinking so that when we come back in whole group, I can think, okay, I want this group to share because they had this idea and this strategy, and then I want this group to share because I knew they did this, and kind of being strategic in how you want to share out in whole group. But that way you have a game plan when you get back to whole group because you know how kids approach the problem. And that's the next part is you come back in whole group and talk about the problem, and you either come to some kind of consensus on what the solution may be or might not be, or things like that. So let me give you a little example because this is, like I said, the hardest component, and I will have a major long video about this. But instead of posing to the kids, I have 6 ants. Each ant has 6 legs. How many legs do the ants have? something like that, where it's a simple like multiplication problem and there's a bunch of them all the same, you know what I mean? You could post to the kids, I have ants in my house. I counted between 35 and 45 legs. How many ants could I have seen? Now, that's a lot of different solutions there could be, and a lot of ways to get to that, and a lot of multiplication the kids are going to be doing. Ultimately, we want them to be doing a bunch of math in one problem that is highly engaging, rather than a bunch of pages of math where they are dreading getting through it. That is the ultimate goal. Opening a problem up so it's more open, it's more engaging, and it's deeper so that they are really thinking about it. And notice I put this in right after review and number sense. I haven't talked about the concept yet. This is how I'm getting the concept to my kids. I'm not talking about multiplication before. I'm giving this to my kids first. Okay, and that brings me to the fourth component. And the fourth component is after that, finally talking about concept. So this is when I might introduce vocabulary. So then I might teach them the word multiplication, equal groups, area, arrays, teaching them the vocabulary after they've come in contact with the concept, and then practicing the concept. What I'm not doing in this fourth stage is practicing formulas and algorithms and things I've told them now do it 100 times. What I am doing is helping my students further develop their idea of whatever concept we're on. And there's some things you need for this fourth component too. You need hands-on manipulatives and or visuals. And really, they're the same because the manipulatives give your students visuals. That's what they do. You can also give your students visuals on the screen or on the iPad or whatever, however, visuals. So if I'm introducing the concept of area or perimeter, before I ever even say area, my kids are going to do a high cognitive demand problem that has to do with that concept, where they're really grappling with the idea of area. And then I'm going to maybe introduce them to the vocabulary of area, and then I'm going to have a ton of visuals instead of a ton of numbers. So before I put in all the numbers, I try to stick with visuals, and concept as long as I can. So with area and perimeter, a lot of times we go to the numbers so fast because we want it to be fast. We want them to just multiply, just add, so you can get that score on that test tomorrow because they only gave us 2 weeks to teach this concept. Just get it, please. And that's what we do a lot, and we don't leave our kids with a really deep understanding of the concept. So keeping numbers out of it. Measurement, also similar. Keeping numbers out of it as long as you can to focus on that concept with a ton of visuals, a ton of drawing, a ton of manipulatives, and things like that, where the students are really getting that deep concept. So I spend like 5 minutes on that. Because if I can get my students to understand a concept, they don't need to do it for 25 minutes. And they can also do it in a math station. And then I can do my small groups with the kids who didn't get that concept, so I can try it in a different way to get that concept to them. So my students that get the concept after one problem, they're ready for math stations. That's where their practice can be. And then I can really hone in on those kids that need more help developing that concept. So those are the 4 components that make a high quality math lesson, like the lessons I use in my classroom. Some of the benefits of using these kind of lessons. 1, it helps your students begin to develop a deeper awareness and understanding of the concepts you're covering. And it also is much more engaging. They're really actually coming in contact with mathematics like it would be in the real world. And it is so cool. It is like a really awesome puzzle, because that's what math is. It's like a really awesome video game that they have to figure out. And kids and humans love that. We love figuring things out. Our brain loves to logically solve something. So your kids are going to be just really engaged in math time and really excited for it and ready for it. And they're also going to be deeper thinkers. Now, it may take longer. And that's the frustrating part, is because we're often not given a lot of time. If we practice making connections, our brain starts getting faster at it. So students make connections between multiplication to area to fractions. If you are helping them be connection makers every day, they start doing that faster. And it will take some time, but you will begin to see the growth and you'll begin to see the payoff, I promise. So I hope those 4 components can help you begin to look at some of your math lessons and how you can maybe incorporate some of those or tweak some of the parts to get it a little more deeper, more conceptual, and more engaging for your students so that they're really becoming mental mathematicians. And always remember, math is natural. happy teaching.